The following presentation is a descriptive guide to the need to correctly solve energy over the next decade. This presentation has been peer-reviewed by leading PhD physicists at national laboratories around the country. There is no debate on the numbers within an order of magnitude. I prepared the following presentation for Dr. Ed Moses, Director of the National Ignition Facility at Lawrence Livermore National Laboratories. The figures you're about to see may seem both perplexing as well as disturbing, but I assure you they are accurate, well within an order of magnitude. Keep in mind the context. For the last 40 years, the population of the United States has been roughly 4% of the worldwide population. Yet at the same time, we have consistently used 28% of the world's energy resources per year. It is only within the last year that another country has for the first time used more energy in a year's period than the United States. Now, that country, of course, was China. Having 4% of the population and consuming 28% of the energy is certainly not sustainable in today's age of rapid travel, internet, and instant communications. Why? Because other peoples in other countries aspire to have a quality of life similar to that of the West. In order to do so, that creates the increased demand of energy. When all countries begin to equalize energy based on that consumed in the West, this would require a total increase of annual energy production of roughly 10-fold. Now, let's look at the presentation. The title of this presentation, My Favorite Element, was in honor of Dr. Ed Moses, Director of the National Ignition Facility at Lawrence Livermore National Laboratories. Dr. Moses himself has delivered a series of lectures which he titled Hydrogen, My Favorite Element. I start off with a picture taken of my science fair project in 1971. In 1971, I developed something called a nuclear magnetic resonance spectrometer long before nuclear magnetic resonance was used as a diagnostic tool for medicine. And in fact, in the early 1970s, nuclear magnetic resonance had not even been developed as a means of spectroscopy except in very advanced scientific laboratories. Notice at the bottom of the project there is a very large magnet. That is a 4,000 Gauss magnet with large pole pieces. The purpose of the project was to flip over, resonate, and precess hydrogen atoms in other compounds so that we could do what we call chemical spectroscopy. The project took top honors in physics in 1971 at the International Science and Engineering Fair in Kansas City, Missouri. And I, in fact, was presented an honor by Dr. Glenn Seaborg, who was the past director of the United States Atomic Energy Commission. The reason I showed this slide in my presentation at Lawrence Livermore Labs relates to the fact that I am not a practicing PhD level physicist, but I do know more than the average bear, so to speak, when it comes to nuclear physics and science. Worldwide, in the year 2050, energy use in all energy sections, including transportation, electrical power, agriculture, and potable water production and transportation, is projected to be 3.2 times 10 to the 21st joules, or 3.2 zettajoules. This is based on a population of 9 billion people worldwide, and this is based on the preponderance of these people in countries other than the West rising up and demanding a style of life much greater than they currently have based on energy use similar to that in the West. Energy contained in world natural gas reserves is currently known to be 6.9 times 10 to the 21st joules, or 6.9 zettajoules. This means that all remaining natural gas could power the entire 2050 demand for energy for only 2.15 years. Energy contained in the world petroleum reserves, which is what we call technically producible, is 7.9 times 10 to the 21st joules, or 7.9 zettajoules. This means that all remaining oil could power the entire 2050 worldwide energy requirements for only 2.46 years. Known energy contained in world coal reserves is set at 2.4 times 10 to the 22nd, or 24 zettajoules. All remaining coal could power the entire 2050 world energy requirements for 7.5 years. Energy produced by every living plant in the world through photosynthesis, because that energy comes from sunlight, is 1.5 times 10 to the 21st joules, or 1.5 zettajoules. Thus, if every single living land and ocean plant in the world was replaced by solar cells having equal square area, we could only power 47% of the world energy requirements in the year 2050. Clearly, solar cells are not the answer for what we call backbone power. As can be seen by the above previous 5 bullet points, we have a problem, and there are only 2 solutions. The first solution is a worldwide population reduction of roughly a factor of 10. That is the Malthusian solution called for by the Sustainability Movement's doctrine and Agenda 21. The preferred solution is to solve energy through mass-to-energy conversion. Using Einstein's special theory of relativity, the formula states that energy is equal to mass times the velocity of light squared. The velocity of light is 297 million meters per second. Square that, and we have roughly 10 to the 16th, which is an enormous number. This means 1 gram of mass has the equivalent energy of burning 735 million gallons of gasoline. How do we do this? Well, there are 3 ways. The first way is fission, and we are currently using fission and have been since World War II. The second way is fusion. We know fusion works because fusion is used in what we call thermonuclear military warheads. However, we have not yet mastered the control of fusion in a benign laboratory or commercial environment. That's the challenge. The third way to do this is matter-antimatter annihilation. In the case of matter-antimatter annihilation, that literally would give us 10 to the 16th, which is in fact the holy grail of energy conversion from mass. But the ability to actually do matter-antimatter annihilation on a commercial scale on Earth is problematic, to say the least. It's something that we may be able to figure out, but it's 500 years away, maybe 1,000 years away. The challenges are enormous. So we set aside matter-antimatter annihilation as being a scientist's dream. fusion is the only realistic solution. In 1976, the Energy Research and Development Administration, or ERDA, which was the predecessor to our current Department of Energy, published a chart showing various policy and funding options for the magnetic fusion energy research program, what is commonly referred to as tokamak. Each option, called a logic level, described how the level of funding for the research would determine when practical fusion power would become available. The most aggressive profile, logic level 5, proposed that a budget of approximately $600 million a year would put the fusion program on a path to operate a demonstrable reactor by 1990. At the other end of the scale, logic level 1 was set at a level of about $150 million per year, again in 1980 dollars. And this was the option which colloquially is described as the fusion never level, because the funding never reaches the level where the remaining scientific challenges in fusion can be overcome. The U.S. fusion program has been at the fusion never level or equivalent, and in fact below, for the last 30 years. The total 2011 U.S. expenditure for medical and scientific research in the United States alone exceeded $95 billion. However, the projected 2013 United States Department of Energy non-National Nuclear Safety Administration fusion research budget is set at less than $425 million. And of that, over 95% is pledged to ITER contractual obligation fulfillment. ITER is a project consisting of several different countries, in fact 7 countries. The United States is only a 9% partner, and ITER in fact is run by the United Nations. The project is located in the south of France. Currently, ITER is set to demonstrate a controlled nuclear fusion reaction in 2027, which from our perspective is about 5 years too late. Therefore, it's incumbent upon the American people to come together and cooperate with scientific laboratories and research institutions to develop fusion power. It is the only realistic solution for mankind beyond 2050.